Good morning, everyone. This is Nigel from KETIV Technologies, application engineer here. Today, I'm joined with Joe Meridian,
Good morning.
one of our subscription managers, and Jorge, who's in Northern California today. Hey, Jorge, how's it going?
Good, good.
All right. So today, I'm sure you all know, we're going to do a webcast here on Nastran In-CAD, which happens to be one of the many simulation tools that Autodesk does offer, and we're going to go over a little bit of that. So let's look at the agenda for today. So today, like I said, we're going to go over Nastran In-CAD. Jorge will be doing a short demonstration, and then Joe will kind of explain here what's happening at July 31st. That happens to be a very important date for us as well as our customers. Some incentives, some Q&A. In regards to the Q&A, we will answer any and all questions you do have for us. Feel free to type them into your questions pane at the bottom of your GoToWebinar panel that you have on your screen, and we'll make sure to cover those at the end of the session today. So without further ado, I'll go ahead and pass it on to Joe and Jorge, and let's get started.
Yeah, thanks everybody for attending. As Nigel mentioned, I'm Joe Meridian. I'm on the subscription team here at KETIV Technologies. And one of the things that we want to talk about today is Nastran In-CAD. We spend a lot of time working with our customers closely and also working with Autodesk closely to understand the needs and the wants of engineers, designers, analysts, things like that. So I want to take some time today to show you a couple of the things that Nastran In-CAD can solve. And Jorge is going to do a technical demonstration which will be of great value to you. So first, we've compiled some of the three major questions that are asked by engineers in today's engineering world. And one of them is, will my design fail? I'm sure this is something most of you are worried about. A failure on design is really one of the worst things that can happen to it. So, you want to know when that's going to happen, how much it's going to take to make that happen, why it happened, things like that. These are all things that Nastran In-CAD can help with. Can my design be optimized? Many of you may have had a design that's been around for a long time. It does very well, it's reliable, it's not going to break, but it might be twice as heavy as it could be if it was optimized. And then, one of the other things is, how can I get to market sooner? It's a competitive world out there. There's a lot of different manufacturing technologies available today, and that's really speeding up the time, the design time, and essentially helping companies like yours get to market sooner, which is something that's very important in today's world. So Jorge's going to do a demonstration today. He's really going to focus on, why will my design fail? Will it fail? And then also, how can I get to market sooner? So we really only have time to cover two of these today. However, I think there are very important two things to cover. So I'm going to have Jorge start on the demo now. We're going to get going on this so you guys can see this tool in action. So go ahead, Jorge. Go ahead and start with that.
All right, thanks, Joe. Just really quickly, make sure you do stick around to the end. We'll try and make the demonstration somewhat quickly, but at the end we are going to talk about, something that we're going live with today as far as some incentives, and try and get you to think a little more seriously about going with Nastran In-CAD. But like Joe said, we're going to discuss a little bit more about, will my design fail? What can I do with that? And as far as getting to market sooner, we're really talking more about reducing or eliminating prototypes, right? So that you don't have to do it as much, or when you do it, it's going to be almost your first run, really. So those are the types of things we want to do with something like Nastran In-CAD, for example. So when we're talking about will my design fail, we're going to take a look at three different scenarios today. First, we're going to take a look at a scenario where, is my assembly or my product design going to be susceptible to vibration? Maybe some small vibrations that I need to worry about. So that's one thing we'll see today. We'll also take a look at fatigue and just standard failure of a part. Over its lifetime. Is it going to be infinite? Is it going to break after a certain amount of cycles, which is okay for me? Maybe we want to warranty it in a specific fashion. So these are things that it can give us more confidence in. And we'll also do some thermal loading. I think a lot of times when we talk about Nastran, that's one of the things we kind of keep just saying, oh, and it does this as well. So I wanted to make sure I spent at least some time with that as well, letting everybody know what type of thermal loading we can actually do inside of Nastran In-CAD. So without further ado, we're going to go into the demonstration, but again, please stick around to the end here. There's some very important information about licensing and what things you can take advantage of today. So for the first example we're going to work on today, we're going to take a look at this fork crown, which is for a bicycle design. So I'm going to try and touch a little bit on multiple customers today. I know we have a lot of you that might be industrial machine designers. Some of you are consumer products. Some of you might be somewhere in the middle or around that, right? But might need to even take care of thermal stuff. So we'll try and cover all the bases today. So the first one we're going to look at again is this fork crown. What I'll do is I'm actually going to open this one part on its own so we can take a closer peek at this in Nastran In-CAD. So what we'll do is, in order to get into Nastran, first of all, don't forget it's embedded. It can be inside of Inventor or SolidWorks, and it's very easy to get to. For any of you who have used Inventor Professional FEA capabilities, you usually go to the Environments tab and go to Stress Analysis. But in here, we'll have Autodesk Nastran In-CAD, which is a network license that can be shared amongst multiple people. So now that we've got this this part running inside of Nastran In-CAD, one of the things we can start doing here is start to identify what type of materials we're going to use. We'll go over some of these and some of the other examples as well, but for now, we'll notice that there is actually aluminum in here already selected for me, so I can go ahead and move forward with this part. Now, it's a pretty straightforward interface, I like to think, where if you want to start adding the constraints as far as how this is going to be held down, we can very easily go to our constraints options here and be able to say that this is a fixed constraint. Notice there are other options in here where we can, if we knew that there was symmetry along this, we can actually do symmetry as well, which we'll utilize in just a bit as well. So, once we've tied down where it's being held from, then we can start applying loads to this as well. And so what we'll do here is we'll apply a force, but notice there are a lot of different ways we can apply forces here. It could be a pressure, it could be a bearing load, it could be an enforced motion for that matter as well. So we can do some actual displacement of components and actual motion that we can see inside of Nastran as well. So we'll do a force, and we're going to do it in the Z direction, negative, right in here. So we can go, and of course we want to select our face, of course. So we'll select the face, click OK, and now we have our force here we can see visually in here. The next thing is the meshing. So meshing is pretty simple to do inside of Nastran In-CAD. We'll notice here there's some settings where we can manipulate this and tell it what size we want, if we want it to round down, round up, or make sure basically that we have enough elements going across this. Usually you want at least 2 or 3 elements going across a face. So we can very easily just come here, generate a mesh, and be able to move this part forward in order to do a simulation. We'll go ahead and run this first. And so this is just a kind of straightforward, a stress analysis that we want to take a look at, so we can see if we can, change the design, maybe optimize it a little bit more, make it a little bit smaller. There are other ways inside of Inventor that we can do that, by the way, using the shape generator, which we have videos from our Autodesk Virtual Academy also. But for now, we'll go ahead and take a look at these results first. Let's take a quick peek at displacement. So by just double-clicking on the results here, I can go to displacement very quickly. I'm seeing an overall displacement, and it is magnified here, so it is just 0.004 inches of displacement. We can also select that we want to see displacement in a specific axis, if that's what we're worried about. And at any time, we can also change to what we want to look at. So if I want to look at stress instead, for example, there's these nice little pull downs so we can quickly get to that information and be able to see what type of stress we're seeing. Maybe we want to see von Mises, for example. We have all the different options right inside of this list as well. So I hope you're seeing so far that it's very easy to get to these results. It's very easy to manipulate, take a closer look at. We can do things like animation as well, and even probe, so we can see along, maybe there's a specific area that we want to take a closer look at what that stress is. We can easily probe that as well and take a closer look at it if we wanted to. So looking at the maximum here, I can see that we're at 23,000. So maybe we want to start taking a look at, let's optimize this a little bit more. So because we're inside of Inventor, you can easily get out of that environment and start to make some edits to this actual sketch and change this part. So that's, again, part of the nice thing about using it embedded inside of Inventor, so we don't have to exit or anything like that. We just simply come in here and make the changes. So I'll make some quick changes to some of this geometry to make it just a little bit smaller, a little bit lighter, a little easier for everybody to, have a lighter bicycle, right? We'll make one more change here. And notice that I can just double click the extrusion, come in here and start making changes to these, these dimensions. So we'll change this up. And we'll change this dimension as well, making it much smaller. We'll just do a quick update now that we've made those changes. And what's great is now that I've made those, all those surfaces are still there, so it's not going to drastically change my, the simulation, but it changes it enough where it needs to do a mesh again. So all we have to do is just simply say we need to regenerate the mesh, kind of like an update basically. But all my loads, all my constraints are still there, and I can see them on the left-hand side here. Now that we've done that, we can just simply run this one more time. And very quickly here, we're able to take a look at those results again. We'll take a quick look at von Mises. Notice this is a nice way to be able to kind of get to that shortcut of seeing the von Mises, by the way, so I don't have to necessarily go through this drop down. And we can still see a little bit more about what's going on here. We can find the max. And now we want to see, well, that does kind of go beyond it, but at what point is it actually going to break? How many cycles is it going to go through before this is going to be an issue? So what we can do is I'm going to take this analysis and duplicate it actually, so I can keep that in place and go back to it if I want to. And now I'm going to create one for a fatigue analysis. So once I do that, I can edit this analysis and say that I want to do a fatigue. You notice we have a lot of different modes we can use, like buckling, pre-stress static. We can do frequency response as well. But right now, we're going to go to fatigue analysis. And now that we've done that, we need to just do a couple more things. The first thing is we need to go to the material actually and do a quick edit so that we can actually apply nonlinear information to it. So, I'm sorry, not nonlinear, fatigue information to it. So what this is going to give us is the ability to come in here and say, well, what is the slope of this? What is the maximum or yield stress? How many cycles? What the endurance slope is, once it reaches that. And finally, the K factor or surface finish or corrosion, depending on what you're working on. So right now we're looking at large number of cycles because we're at 1,000. If we take a quick look at the plot, we can take a look at that and verify that we've given it the right information for it as well. And finally, one more thing is we need to go to our fatigue setup where we can actually tell it what we want it to solve for, von Mises. All right, and actually one more thing we need to do as well. And for this actual material, we want to apply a table to it. And so what this allows us to do is to be able to tell it, how we want it to apply the actual forces to it as well. So we've completely gone through here and been able to set up our fatigue analysis very easily, as you see, by simply making some edits throughout the the entire the setup of this model, so we can get a fatigue analysis out of it. So let me move forward here. We're starting to come closer and closer to the 10:30 mark here. So let me actually change gears here a little bit. And now I want to show you a different example where we're going to discuss a something that I actually talked about with a customer prior to this. So there could be some of you that might have a a product that is like a shaker table, if you will. You know, it might be conveying food if it's food and beverage. It might be, you know, raw material, different things that you might need like a shaker table for to move product along to a conveyor or filter or something like that. So we had a customer that actually had a similar situation that they needed to be able to simulate something like this. So I thought this was a great example, something that's kind of a little bit out of the ordinary, but you know, to show you some of the things that it can do. What I've done here is I've actually created an IPT or a part that is all, you know, it's not an assembly, it's an actual multi-body part that, you know, this shows you that you can do some upfront work. So you don't have to wait to the very end. You don't have to be a PhD necessarily to do some of this information, get some of this information up front before you move forward. So we just got a simple structure here that holds it up, and then in here we have some springs that's going to actually attach it from one place to the other. So we're going to show you how we do that in Nastran In-CAD. The first thing we want to identify is that, well, you know, these are really thin bodies. Do I really want to simulate this and try and get a few elements across this? It's going to take a little bit of time. Might not even get you the most accurate results necessarily. So what I like to utilize instead is we have this mid-surfaces option, where we can say identify the mid-surface of these components right here. I'll show you in a moment why we are not doing it to all of them. I'm picking which ones I actually want to use. So it's going to find mid-surfaces for all of those. So it breaks it down, finds the mid-surfaces. I didn't have to do that myself. Now the other part is these. Now these are more important because there's actually going to be connections in here, or springs. So instead of using the mid-surfaces tool, what we'll do is we'll use our idealizations here to be able to say that we want to apply a material to this. We'll select the material. Steel mild. And actually, let me go back here. I forgot to mention that I wanted to make this a shell element. So this allows me to tell it the actual thickness that I want for this, for all of these things here. So I'll select this face here, these faces here, and this last one here. And finally, we'll choose a material for it. There we go. So these right here have a steel material assigned to it, have a thickness of 0.25. We could do a mix, by the way. If you had multiple ones, you just create different idealizations with shell elements as well. Now with those done, the last thing is I want to actually add connections to this. So a lot of you might think, well, I would have modeled the springs. That's not necessarily the best way to approach this. There's actually a tool in here that allows us to create these connectors. So I can create a brand new connector, and there's different options here from rods to cables, bolts, as if you want to do an actual bolt design for this. But I'm going to choose spring here. Once I choose spring, then we can say what stiffness we want for it, for example, and then that way we can have it, you know, be as realistic as possible here. And then as far as actually placing it, it really is as simple as just selecting these midpoints here of these circles to be able to actually place it in. And there's some nice tools here to be able to duplicate this, so we don't have to come in here and start from scratch every single time and type in the values, because there might be more than just this one value in here that you need to specify. So we'll just add some more springs in here. It's actually easier to do it this way instead of bringing in springs and trying to mesh it and everything. And this really is the more accurate way to do it anyways. All right, all those in place. The last thing I want to do is I want to set up what type of analysis this is. And what we'll do is we'll edit it and say that this is a normal modes analysis. So it's going to find the natural frequencies in here, so I can see if it is susceptible to the smaller vibrations or frequencies. But then we can also assign constraints. Where is it going to be held down by? So let's say it's actually positioned down here, you know, on the floor. It might be on another system or a structure for that matter. And we'll say that it's fixed. For that matter, we can also add a load. Maybe there is an actual load that you're applying on the top here because as it's shaking, it actually has a load on it, right? Or you can just do this first to find out if it is susceptible to, some of the natural frequencies. And then in the mesh settings here, we have the ability here to go linear so that we are able to go just straight to these corners and then be able to make sure that we have enough elements inside of it, and again, really easily be able to create the meshing for all this information in here as well. We'll let it take a moment here to mesh. We now have that, and in the interest of time, this does take a couple minutes to run, so I have a model here that's already been done. We'll take a quick look at that. All right, and now that we have that, what we'll do is we'll load the results. What it does actually, so that you can save this file, in a smaller format, it does create the actual results on a separate file, so that if you still wanted to, share this design with somebody else, you absolutely could. But now this gives me the ability to actually take a look at the results. We'll go ahead and take a look at those. We can see we can see it in a deform mode. We can just see the actual contours of it, and we can also see at what frequencies this is happening. So at frequency 1, what's happening? What if I go to frequency 10? What is it tending to do? So this isn't telling you that it's going to break at this point, but it's just letting you know, what's the tendency going to be of this assembly as you actually start working with it. So we have some higher stresses right here. Some more stresses right here as well in this panel that it's going to experience, and we can start to kind of get a better idea of what these, what the displacement might be at these different frequencies, so you can have a better idea of how you might want to pursue this design. All right, now that we finished that, we'll move into our last example, which is thermal. Okay. And in here, what we're looking at is we're going to look at a piston sleeve. So this piston sleeve, what it is the ability, or I'm sorry, it's actually for a yogurt filling cup. So think of a large industrial machine. We have some cups that need to be filled with yogurt, and what happens is when you move it, when you change what product type it's going to be, maybe it's from peaches to strawberries or something like that, then you need to clean out the system. And so it has to go through a washing that needs to happen at a specific heat to be able to make sure that we are able to clean it fully. So what we can do inside of here is, again, go to our environments here, go into Nastran In-CAD, and be able to set up an initial condition of temperature and then what it's actually going to be hit with. So for this example, what we have is there's a stainless steel component here for the sleeve, and the actual component that comes down is made out of a different material. So we want to see if if the two materials are too different from each other, in that one might expand faster than the other. So what we can do now is in these materials we can actually edit them and turn on the thermal capability of it, and be able to see some of those thermal loading that's going to happen to these materials. So now with those thermal capabilities on, what we can do then is be able to create these loads that allow us to say, well, what is the actual thermal degrees that's going to be thrown on this, as well as what is the initial conditions for it as well. So we're saying this is 294, basically room temperature in kelvins. And then the other thing we can do here is we haven't talked too much yet about the having an assembly that moves, but in here, if we were to do this, we can actually have surface contact on this so that it automatically picks up that there's a sliding motion that can happen through here, and what the max distance is between that, so that if it actually does touch each other, it'll know that it cannot move left or right, for example. So in the interest of time here, we have this one that's already been generated. I'll go ahead and load these results, and we can take a look at this too. All right, with those results now, what we can do is we can take a quick peek at displacement, for example. What we might want to do again is make sure that as this is, has this thermal loading, again, this is exaggerated, we see that this tends to expand a lot faster than this one down here, than the sleeve. So we might want to consider then making the actual bore diameter for this quite larger in order to account for that. We are seeing it in the x-axis, by the way, too, right now. So this is when we can finish this Nastran In-CAD solving, and we can go back, make that change, come back, run it again, and be able to see what those results look like. So we can, again, at any time be able to go from the displacement to look at the stress curve for this and see what kind of stresses we're going to see for it as well, for von Mises. And take a closer look at that thermal loading, and we see that the sleeve is experiencing some thermal loading a little bit faster than the sleeve as well, than the piston itself. So those are just 3 quick examples I wanted to show you. There is a lot more that we can do, of course, inside of Nastran In-CAD. We just kind of skimmed the surface. To bring up some other examples, we're talking about heat transfer as well, where, if you look at this brake design, we wanted to see as it's spinning what type of heat is transferring from one component to another. Nonlinear stress as well, so we can do plastics in here, like we talked about the piston in that sleeve, and even buckling as well. Again, we're skimming the surface, but these are some examples that we plan to show you in future webinars as well. And don't forget that this isn't the only simulation offering we have. There's Simulation Mechanical, which is a standalone product outside of Inventor. It still is CAD neutral and is able to bring in files from SolidWorks, Inventor, Pro-E, CATIA, you name it. And it has a lot of this stuff that Nastran In-CAD does, as well as a few others that you can do, and we've discussed in prior webinars. And then if you have Inventor FEA, you can, or Inventor Professional, you can actually import that information into Nastran In-CAD if you started to use that for your upfront design as well. So that is another offering that you have available to you as well in order to do a static analysis, modal analysis, and dynamic simulation or kinematics. So now I'll go ahead and pass it over to Joe. Please keep sticking around with us. We have a few announcements to make and why you might want to decide to go with Nastran now versus later.
Yeah, thank you, Jorge, and thank you everybody for staying on with us here through this. So we want to talk a little bit about why do this today. So as many of you know, I'm looking at the attendance here on this webcast. I see a lot of you have attended previous webcasts that we've done that relate a little bit more towards licensing options. We had one a couple weeks ago. We're going to have another one a week from today. So Autodesk had announced over a year ago that they're going to discontinue perpetual licenses. So we've been talking about this for almost a year and a half now. And I put this table up here to kind of show you where we're at in this transition. Everything that has been grayed out has already happened. You can no longer buy a perpetual license of non-suite licenses like AutoCAD or Inventor, Revit, things like that. You can still buy perpetual licenses between now and the end of this month. July 31st, 2016 is the last day that you're going to have the availability to purchase a perpetual license of software. This means, Product Design Suite, which is probably the most common, license that is owned by the attendants on this webcast. Things like that, simulation, Nastran In-CAD's included, Vault Professional, all of those are available as perpetual licenses until the end of this month. So what I want to show you is the next slide here is really going to cover all of your options now. So right now, like I mentioned, you can still buy perpetual licenses of suites, simulation tools, data management tools, and other items like that. That's available. If you have existing tools, let's say you have enough licenses, you might already have a Nastran In-CAD, you're just kind of on this webcast to review, you can continue to renew your maintenance. That'll keep your perpetual license up to date. It'll prevent you from ever having to switch over to the term-based subscription model only, and it'll allow you to continue to get updates, support from Autodesk, previous version use, and things like that. And you also have the availability to subscribe. So right now, we really have the most options available that we've ever had. You can buy a perpetual license, you can continue to renew what you have, and you can also subscribe to Nastran In-CAD. You can subscribe to AutoCAD, Vault, There's a lot of different options. Let's go one more slide forward, please, Jorge. So just to review, most of the people that are on this webcast have a maintenance plan. This is what keeps your perpetual license up to date. In addition to the latest software releases, you actually own the rights to this license. So with or without a maintenance plan, you get to own a perpetual license. It's yours to keep. The maintenance plan is what provides all the benefits you see here. Latest software releases, Autodesk cloud services such as cloud storage, rendering, tools like Fusion 360, and also viewers. And then you get basic email support from Autodesk as well. Moving forward onto the next slide here, this is what your options are going to be after August 1st. So after August 1st, we are no longer going to be able to sell you perpetual licenses of any software. So what you're going to have is you're going to be able to renew your maintenance plan moving forward. That will never change. You can continue to renew that for as long as you like, and nothing's really going to change for those licenses that you have. But for all new purchases, the only option you're going to have after August 1st is to subscribe. And we have options as little as a month. You can subscribe to, let's say, an Inventor Professional license for a month. If you're hiring an engineer, for a certain product, or you just want to get in at a very low cost, you can rent tools on a monthly basis. We also have plans up to 36 months, and if you renew for 36 months, then you get some sort of incentive to do it longer term. Many of you might see you have a project that's going to be a year long, and it would make sense for you to purchase an annual subscription just to get your user access to the same tools everybody has on your team, but just for 1 year, because after that you may no longer have a need for that engineer, you may no longer have a need to allocate resources to that project. So that is one thing that is really good about subscription, is it is flexible. If there's any questions about this, please feel free to type them into the question and answer, the question section on the right-hand side of your screen, and we'll be more than happy to answer those in just a minute here. So the next thing I want to get into is the incentives that are available to you right now. So number one, the majority of our customers have a maintenance or a subscription plan. If any of you have one of those that is going to be due for renewal in the next 90 days or so, you can renew that now, and in conjunction with that, you can add new product and save up to 40%. This doesn't mean that every product is included. However, Nastran In-CAD is included in this. So I'm going to say that again. If you have a maintenance or a subscription plan that is going to be due for renewal between now and October 22nd, if you renew that, you can add, let's say, a Nastran In-CAD and save 40% off of that license. And that is going to work for an annual subscription or for a perpetual license. So it's a pretty significant savings, almost half off of the normal MSRP of that license. The other thing that we are offering, not everybody here is going to be able to renew a maintenance or subscription plan in the next 90 days. You may have done it a few months ago. It may not be due for another 6 months. So because of that, we wanted to offer something that everybody could take advantage of. And what we're doing here is we're going to offer a free 4-hour jumpstart training session with any Nastran In-CAD purchase. So if you purchase an annual subscription or a perpetual license of Nastran In-CAD, we're going to do a 4-hour session probably sometime in August or September. We haven't booked the dates yet. We want to see if anyone in here is interested in this, and then we can set the dates up and work on that for you. I'm going to go over what this entails in a minute here, and Jorge is going to walk us through that as well. But just so you know, 40% off if you renew, and then free training. You can take advantage of both of those. If you qualify for the 40% off, we will also offer you the Jumpstart training at no cost. So just to know what this looks like, if you want to try Nastran In-CAD out for a year, the annual rental is about $3,570. If you get if you qualify for 40% off, it's going to knock a fair chunk off of that price. But you're essentially getting a Jumpstart package to really learn how to use the tool and access to the tool for a year for about $3,500. So it's really inexpensive for a simulation tool that has this much capability. And I'm going to actually go through, what we're going to cover in this Jumpstart training for you pretty quickly here. So linear static analysis, this is something that we showed a little bit of today. This is something that you'll learn how to do. Also, buckling analysis, heat transfer, and thermal stress analysis, and then metal forming. I'm going to let Jorge go through this a little bit more since he is one of our technical specialists. Jorge, go ahead and talk to them a little bit about these different topics covered in our training session.
Yeah, so this is just a jump start training, right? This means that we'll do an overview of how to do these things here, as well as give you a few tips and best practices on when you're running a simulation. What are some of the things you want to look for? Some of the things that when something goes wrong, what you might want to do as well. So this kind of gets you started. And then after that, then we can talk about what areas of you need to dive into a little further, right? But at least this way you're able to start using it, and then also get a little more hands-on experience, if you will, also. At no extra cost, like Joe said, if you guys go and go ahead and get that. Also, by the way, just a quick note, I know this might be a little too soon, but there is a standard Nastran class training we're doing next week, by the way. So if by any chance anyone out there is interested, do let us know. It is early next week that we have a standard one going on too.
Yeah, thanks for bringing that up, Jorge. I didn't mention that. So we do have a 2-day standard Nastran In-CAD course that's really a fundamentals course that's scheduled for Monday and Tuesday of next week. They're 2 full days here in our Brea location, or they can be held online. We do have some availability. We had one of our customers actually had to reschedule, so we have a little bit of availability in that course. If there's anyone that wants to take advantage of that, please let us know. I know it's late, last minute. We really would have to talk about getting you enrolled in that today. So because of that, we're offering a pretty substantial discount on that course. So if that's something that you're interested in taking, if you have some availability next week, we'd be happy to work with you and make sure that you can attend that course if you want to do so. Otherwise, we do have these standard courses about once a quarter. And then, like we mentioned, we have the 4-hour Jumpstart training, which we're going to host sometime in the next month or two for anyone that purchases a Nastran In-CAD between now and July 31st. So, if you have any questions about that, please let us know. And then I just want to reiterate here, if we go to the next slide, I just want to show you the next steps. So purchase perpetual licenses. We have literally 21 days until the end of the month. 3 weeks from today is the last business day of July. It's the last day that you can purchase any perpetual licenses that you may need. Lock in your maintenance rates is another thing that many of our customers are doing. Because of this shift to the term-based licensing, because new maintenance plans are not going to be available, and we've been working with customers to lock in what they have, consolidate their licenses, renew for as long as possible, which is 3 years, which will lock in today's rates, and protect you from any increases over the next 3 years. It's really the most cost-effective way to make sure everything you own is maintained, and to make sure that you can keep your platform the way it is now for as long as possible. And then finally, partner with KETIV for Nastran In-CAD training and support. So we have an in-house support team, our Lifeline team here, that is well versed on things like Inventor, AutoCAD, Revit, tools like that. But in addition, we can support and train on Nastran In-CAD, simulation mechanical, some of the more advanced FEA tools that are available to you. So definitely reach out to us if you want to see a more in-depth demonstration about products that will be more in tune with your organization. Then it would be really good to talk to us, and we can set that up for you. And then if you have an existing Nastran In-CAD or simulation product, think about adding KETIV Lifeline if you haven't already. We can definitely support any issues that you do have. And if it's something that's out of our wheelhouse, we can escalate that to Autodesk and work in conjunction with them to get an answer out to you as quick as possible. Lastly, I just want to review the promotion one more time with you. Renew an existing contract today, save up to 40% on new products like Nastran In-CAD, Vault Professional, Vault Office. Fusion 360 is another tool that's included in that 40% off. We can share the entire list with you upon request. So if you guys want to see that, please type it into the question and we'll get that off to you. In addition, if you purchase a Nastran In-CAD product between now and the end of this month, we will throw in a Jumpstart training session, which will be held here in our Brea office. If you're not local to Southern California, we can do that online as well. But feel free to contact us and get more details about that. Otherwise, I'm going to hand this over to Nigel. He's going to walk us through the question and answer session here. We have seen some questions come in. Remember, if you do have any, feel free to type them into that box, and we'll be happy to answer those for you.
All right. Thank you, Joe. Thank you, Jorge, for giving us that great presentation. It's always a pleasure for sure. So we do have a couple of questions here in the queue. Remember, if you do have those questions, go ahead and type them in to the GoToWebinar panel that you have on the likely right-hand side of your screen. So the first question here comes from Mike, and Mike mentions that Nastran In-CAD available for SolidWorks, question mark?
Yes, so Nastran In-CAD is a plugin. So it plugs into Inventor, and it can also plug into SolidWorks. It's either one or another. You can either buy Nastran In-CAD for Inventor. You can buy Nastran In-CAD for SolidWorks. But yes, it is a plugin. It will plug into either one of those, and it can be used as an In-CAD environment, for you and your team.
Okay, and just so we're clear on that, they're two different products, right? Correct? There's Nastran In-CAD for Inventor, and then there's Nastran In-CAD for SolidWorks?
Yeah, correct. So you can't interchange them. If you have a team with SolidWorks, you can purchase Nastran In-CAD for SolidWorks. If you have a team with Inventor, you can purchase Nastran In-CAD for Inventor. But yeah, they are two separate products. The price is, I think, identical on them. It's just the way that they're deployed is a little bit different.
Cool, and yeah, we can most certainly help you out with that deployment. It's kind of works, at least the Autodesk one for Inventor, works similarly to things like your normal network licenses. They use the same server, or not the same server, but the same program to hand out that licensing, so you can maintain one environment in that sense. Let's see here. Oh, we got another question from Alex, and Alex asks, will this be recorded, and can I watch this because I missed a couple of minutes at the beginning? So yes, you can most certainly watch this over again if you'd like to hear us again. On our YouTube channel, that's KETIV.com YouTube.com/KETIV Technologies. I'll make sure to type that into the chat right now. I'm going to get that sent out. All of our recordings are there, as well as our Autodesk Virtual Academy recordings. And that's our once-a-week learning sessions that we do every Thursday. Anything and everything related to Autodesk products we do. Demonstrations, we introduce new products, fun stuff like that.
Yeah, see, the next question here is from Larry. Larry asks, is Nastran In-CAD a network license? And yes, Larry, it is. So what's really awesome about this tool is, say you have an engineering team of 5 engineers that really don't need to do the advanced FEA more than a couple times a week maybe. You can purchase one Nastran In-CAD license, put that on your network, and then everyone on your team can access that tool. Not at the same time, but they can access it. So let's say, engineer number 1 needs to do some advanced FEA on Monday. He can check the tool out, do everything he needs, check Nastran back in, similar like you would with a network license of Inventor or Product Design Suite. And it can be used by him for that certain amount of time, and then when someone else needs to get it, as long as it's checked back in, they can do it. So you can really share one tool with as many people as you want. You do not need to buy one of these per person, which is a great benefit. The prices that we talked about earlier, the $3,500 was for a network license. So that's a pretty inexpensive way to get a tool for most of your engineers to be able to share.
Yeah.
Thank you, Larry.
So we have covered that. It looks like we don't have any more questions left. But make sure if you do have any questions, go ahead and email info@ketiv.com, or you can go ahead and email our new email handle, which is questions@ketiv.com.
Yeah, questions@ketiv.com. Feel free to email us there. We send out a follow-up email to everybody that was registered and attended this session. We'll get that out to you later today. It'll have that information on there as well. So, I want to thank everybody again for attending. Feel free to reach out to us if you come up with any questions between now and the end of the day, even next week, and we'll be happy to answer those for you.
Definitely. I guess that's everything. Jorge, it looks like your camera's not working right now, but that's okay. Thank you again for joining us, Joe and Jorge, and thank you all for watching today.
Thank you. Have a great day.
Bye.
Bye.